you're falling. Not slowly, not gently. You are being ripped downward at a speed that makes skydiving feel like a lazy afternoon nap. The clouds around you aren't white and fluffy. They're ammonia crystals. They burn. The pressure is building so fast that your ears, your entire skull, begins to compress inward. And the worst part? You haven't even reached the surface yet. Welcome to Jupiter. Now, here's the question that's going to keep you up tonight. Could you actually stand on it? And I don't mean theoretically. I mean you, your body, your bones, your blood, dropped onto the largest planet in our solar system. What actually happens? Because the answer is not what you think. Not even close. Okay, let's rewind for a second. Jupiter. You've seen the pictures. That massive swirling marble, orange, cream, and rust-colored bands wrapping around something incomprehensibly huge. It looks almost peaceful from a distance. But here's the first thing that blows people's minds. Jupiter is 11 times wider than Earth. If Jupiter were a hollow ball, you could fit over 1,300 Earths inside it, just stuffed in there, and it would still have room. It's so massive that technically Jupiter doesn't orbit the Sun the way Earth does. The gravitational center, the point where Jupiter and the Sun actually balance each other, sits outside the surface of the Sun itself. Think about that. Jupiter is so heavy, it yanks the Sun slightly off-center. This is not a normal planet. This is a monster. But here's where it gets interesting, and where most YouTube videos get it totally wrong. When people ask. And yes, that's partially true. But the real story, the real physics of what would happen to a human body on Jupiter, it's so much stranger, so much darker, and honestly, so much more fascinating. Let's go layer by layer. Layer 1, the moment you arrive. Imagine you've been teleported to Jupiter's upper atmosphere. You're just there, floating, no spacecraft, no suit, just you. The first thing you notice is the color. The sky isn't blue. It's a deep, bruised amber. Bands of orange and cream stretch across the horizon like brushstrokes from some alien artist. Lightning crackles in the distance, not the thin, jagged lightning you see in a storm on Earth. Jupiter's lightning bolts are up to 1,000 times more powerful than anything on Earth. One strike could vaporize you before you even had time to process where you were. But let's say you survive the lightning, because the lightning isn't even your biggest problem right now. Your biggest problem is what you can't see. The wind. Jupiter's atmosphere has wind speeds of up to 620 kilometers per hour. That's not a hurricane. That's not even close to what we'd call a storm on Earth. Earth's most violent hurricanes peak around 300 kilometers per hour, and they level cities. Jupiter's baseline wind speed is more than double that. You wouldn't be standing on anything. You'd be flung sideways, tumbling to a sky with no ground in sight, no horizon to orient yourself, just clouds and ammonia and wind that could tear a skyscraper apart like tissue paper. But here's where I need you to stay with me, because this is where the science gets genuinely mind-bending. Layer 2, the layers beneath. Jupiter doesn't have a surface, not in the way Earth does. On Earth, if you fall, you eventually hit something: dirt, rock, the ocean floor. there's a definite boundary between. Jupiter doesn't play by those rules. Instead, as you fall deeper into Jupiter's atmosphere, the gas around you gets thicker and thicker and thicker, not suddenly, but gradually, like sinking into an ocean that slowly turns from water into something denser. Scientists divide Jupiter into layers, and each one is more extreme than the last. The first layer is the one you entered, the upper atmosphere, hydrogen and helium gas swirling at terrifying speeds. Temperature around -145 degrees Celsius at the cloud tops. Cold enough to freeze your lungs instantly if you were somehow breathing the air, which, by the way, you absolutely cannot because there's no oxygen. Just hydrogen, helium, ammonia, and sulfur compounds that smell like rotten eggs mixed with rocket fuel. As you fall deeper, the temperature starts to climb. By the time you've dropped about 50 kilometers in, which happens fast given Jupiter's gravity, the temperature has risen to something closer to Earth's sea level temperature. For one brief, almost poetic moment, you're in a zone that's almost habitable. Except, the pressure is already building to levels that would crush an unprotected human body like an aluminum can under a boot. Fall further. 100 kilometers in, the clouds change. They become denser, darker. The atmosphere transitions into something more like a very thick gas. Still technically gas, but behaving strangely. 200 kilometers, 300, 500. At around 1,000 kilometers deep, something happens that doesn't happen anywhere else in the known solar system. The hydrogen, which has been a gas this entire time, doesn't become a liquid. It becomes something science barely has a name for. Liquid metallic hydrogen. Layer 3, the impossible ocean. Liquid metallic hydrogen. Say that out loud for a second. Liquid metallic hydrogen. This substance doesn't exist anywhere on Earth. We've only barely managed to create tiny amounts of it in laboratories for fractions of a second. It behaves like a metal, but looks like a liquid. It conducts electricity with almost zero resistance. It flows, but also resonates with electrical currents like a wire. And Jupiter has an ocean of it. An ocean that's estimated to be about 40,000 kilometers deep. For reference, the entire diameter of Earth is only about 12,700 kilometers. Jupiter has an ocean of liquid metallic hydrogen that is 3 times the width of our entire planet. This is where Jupiter's magnetic field comes from, the most powerful magnetic field of any planet in our solar system, except the Sun, 16 times more powerful than Earth's. So massive that if you could see it, Jupiter's magnetic field would appear larger than the full moon in our night sky from Earth. And somewhere at the very center of all this, past the liquid metallic hydrogen, past the crushing pressures that make the deepest ocean trenches on Earth look like a kiddie pool, scientists believe there might be a solid core. Maybe. We don't know for sure. We literally cannot know for sure because no instrument we've ever built can survive long enough to reach it. The Galileo probe, NASA's probe specifically designed to enter Jupiter's atmosphere and transmit data, lasted 57 minutes before the pressure and heat destroyed it. 57 minutes. And it made it roughly 150 kilometers deep. Out of tens of thousands. The twist. what actually happens to your body. Okay, let's get back to you. You, the human, dropped into Jupiter. Forget the suit for a moment. Let's just talk about raw physics and what Jupiter's gravity alone would do to you. On Earth, you experience 1 g of gravity. That's the baseline. That's what you've lived your entire life under. Jupiter's surface gravity, at the point where the atmosphere becomes dense enough to even consider A. That means if you weigh 80 kilograms on Earth, you'd effectively weigh 192 kilograms on Jupiter. Your heart, which already has to work hard enough just to pump blood from your feet to your brain here on Earth, would need to work nearly 2.5 times harder. Your lungs would struggle to expand against the weight of your own chest. Your legs, which evolved over millions of years to carry your body weight in Earth gravity, would almost certainly snap under you. The blood in your body would be pulled downward with 2.4 times the normal force. You'd be fighting a constant battle against your own circulation. Cerebral hypoperfusion, not enough blood reaching your brain, would start within seconds. And that's before we even talk about the atmospheric pressure. Earth's atmospheric pressure at sea level is 1 atmosphere, or about 101 kilopascals. Jupiter's pressure at the 100,000. Your body would be compressed, collapsed, and obliterated so completely that there would be no recognizable trace that you had ever existed. Not your bones, not your cells. You would simply cease. What this actually means. Here's where I want to pause. Because I think we often look at these numbers, 100,000 atmospheres, 620 km/h winds, liquid metallic hydrogen, and we nod along and go. But sit with it for a second. Jupiter has existed for 4.5 billion years. It formed before Earth did. It's been spinning, storming, pulling everything in the solar system toward it with its enormous gravity for longer than life has existed on our planet. The Great Red Spot, that massive storm on Jupiter's southern hemisphere, the one that looks like a giant eye staring out at the cosmos, has been raging continuously for at least 350 years, possibly much longer. We have paintings from the 1600s that show the Great Red Spot. People were looking through telescopes and sketching that storm while Shakespeare was still being performed on stage. And it hasn't stopped once. That storm alone is bigger than Earth. Think about what that means. The storms we live through, the ones that shut down cities, that we name and track and fear, last a few days, maybe a week, for a major hurricane. Jupiter has had a single storm continuously for 3.5 centuries. Jupiter doesn't care about us. It doesn't know we exist. It's just out there, spinning, storming, warping space-time slightly with its mass, doing exactly what it's been doing for billions of years. And we're here, on this tiny blue marble, trying to figure out if we could stand on it. There's something deeply humbling about that. Layer 4. But what if we had the perfect suit? Okay, but let's go full science fiction for a minute. What if we could engineer a suit, some future technology, centuries from now, that could withstand everything Jupiter throws at us? The pressure, the temperature, the wind, the gravity. Could you theoretically stand on Jupiter then? Here's the fascinating answer. Even with a perfect, indestructible suit, there's still the problem of where to stand. Jupiter has no solid surface in its outer layers. But, and this is the part that gets genuinely debated among planetary scientists, there may be a solid core deep inside. And if you could somehow get to it, and somehow survive the layers above it, and somehow handle the pressure of 40,000 kilometers of liquid metallic hydrogen pressing down on top of you, you might be able to stand on a surface no human eye has ever seen. On a ground that exists at pressures and temperatures we can barely simulate on Earth. Surrounded by an ocean of conducting liquid metal that stretches up almost to the sky. With a sky that isn't really a sky, just denser and denser layers of gas and liquid blending into each other with no clear boundary. It would be the most alien environment imaginable, and also the most alone you could ever possibly be. Billions of kilometers from Earth, beneath material so thick and crushing that no signal, no radio wave, no light, nothing could escape back to the surface. You'd be completely, totally cut off. The last human in the most extreme place in the solar system. The science angel, what we're actually learning. Now here's the thing that makes all of this not just a thought experiment, but actually relevant. We are actively sending missions to Jupiter. NASA's Juno spacecraft has been orbiting Jupiter since 2016. It's been diving closer to Jupiter than any spacecraft before it, surviving radiation belts intense enough to damage spacecraft electronics, and sending back data that has genuinely shocked scientists. Things we thought we knew about Jupiter? Wrong. Jupiter's atmospheric bands, those beautiful stripes, were thought to be relatively shallow weather patterns. Juno revealed they extend thousands of kilometers deep into the planet. They're not surface features, they're structural. The poles of Jupiter look nothing like what we expected. Instead of banded patterns, the poles are covered in enormous cyclones, dozens of them, locked in geometric formations, perfect polygons of storms, each one the size of a continent, arranged in shapes so precise they look almost artificial. A hexagon of cyclones at the South Pole, an octagon at the North. Nobody predicted this, nobody expected it, and we still don't fully understand why. Jupiter keeps surprising us. And in 2030, NASA's Europa Clipper mission will be studying Europa, one of Jupiter's moons, which has a liquid water ocean beneath its icy surface that contains more water than all of Earth's oceans combined. If there's life anywhere else in our solar system, Europa is one of the most likely candidates. So Jupiter, this gas giant behemoth that would instantly destroy any human who touched it, might be sheltering life on its moon. The monster that can't be touched, guarding something precious. If this video made you feel something, if it shifted even slightly how you think about the universe, hit that like button. Not for the algorithm, just because good ideas deserve to spread. And subscribe if you want more of this. We go deep on the science that actually matters, the stuff that changes how you see the world when you look up at the sky.